Welcome to another tutorial on GCSE and A-level chemistry. Here we're going to start looking at calculations required for both courses. So this video will run through some of the basic calculations needed and some of the key definitions of A-level and GCSE chemistry. So the first definition that we're going to look at here is relative atomic mass. So we're going to give it the symbol here AR. So we're looking at relative atomic mass, which is defined as the average mass of one atom compared to 1/12 of the mass of one atom of carbon-12. Now what this definition is saying is that we're going to use carbon as our benchmark, as our standard starting point for all of our calculations. So just like the degrees Celsius scale, when we're using carbon-12 as our benchmark, we compare everything back to this carbon-12. So one atom of carbon-12 is our starting point. If we say had an atom of hydrogen with one proton and no neutron, we could then say that the mass of a hydrogen atom, being 1/12 of carbon-12, is equal to 1. The carbon-12 would be equal to 12, and then magnesium, as an example, would be equal to 24 if we had the isotope of magnesium that weighs 24. So we have magnesium is double the mass of a carbon-12, or hydrogen here is 1/12 of the mass of carbon-12. So all we're doing is we're setting a benchmark to work from, with carbon-12 being the centre. We can now look at this in terms of a calculation. So let's use carbon-12 as our basic example so we can build an equation for this. Now, first of all, moles is equal to the mass of the substance divided by its relative atomic mass. So the mass of the element that you've got divided by the relative atomic mass of the element, which can be found in the periodic table. So carbon-12 is our example. If we have 12 grams of carbon-12, we've got the relative atomic mass of carbon-12, which is 12. So that gives us 1 mole of carbon-12. So you can see where moles come from, and we can see where the calculation for moles actually appears. Now let's look at another simple example. So let's say we've got magnesium. We've got the relative atomic mass of magnesium is 24. If I have 24 grams of magnesium, we've got moles is equal to mass divided by mR. So if we've got 24 grams of magnesium, we've got the relative atomic mass of magnesium, which is 24. That leaves us with 1 mole of magnesium. It's not always the case that you will have the same mass as relative atomic mass, so it won't always come out that you have exactly 1 mole of a substance. So what you're going to be expected to do is do calculations for moles when you have either more or fewer grams of that substance compared to its number of moles. So let's look at some examples. Now, if we look at calcium, and we use the relative atomic mass from the periodic table, we've got the relative atomic mass of a calcium atom is 40. If we've got 80 grams of calcium, how many moles of calcium do we have? So we've got moles is equal to mass divided by relative atomic mass. So we've got 80 grams divided by its relative atomic mass, which is 40. So here we have 2 moles of calcium. Now we can look at other examples, this time where we have we have a lower mass to the number of moles. So this time, let's look at if we've got lithium, and we've got 1.5 grams of lithium. Lithium has a relative atomic mass of 7, and we're saying we've got 1.5 grams of lithium. So moles is equal to mass divided by relative atomic mass, which is equal to 1.5 divided by the relative atomic mass, and that leaves us with 0.214 moles of lithium. So sometimes you might have more than 1 mole, sometimes you might have less than 1 mole, but that's a very, very simple calculation just for working out basic moles in chemistry. The next key term to look at is the idea of relative formula mass. Now previously we've just looked at relative atomic mass. Now for relative formula mass, all this is is the total of all the different masses of atoms that make up a particular molecule or compound. So my examples here, I've got molecules of oxygen, I've got sodium chloride, aluminium oxide, copper hydroxide, and sodium sulfate. Now what we can do is work out the relative formula mass for each of these different examples here. So example number 1, for our molecules of oxygen, oxygen is made up of 2 atoms of oxygen, each with a relative atomic mass of 16. Now the relative atomic mass is obtained from the periodic table. So for oxygen, the relative formula mass of oxygen molecules is 16 times 2. So the relative formula mass of oxygen molecules is 32 because there are 2 oxygen atoms in there, each with a mass of 16. For sodium chloride, we have 1 sodium atom with a mass of 23. We have a chlorine atom with a mass of 35.5. So our total mass is 58.5 grams per mole of sodium chloride. The next example, Al2O3, aluminium oxide. We've got 2 aluminium atoms, each weighing 27. We've got 3 oxygen atoms, each weighing 16. So our total mass of our aluminium oxide is 102. For copper hydroxide, here we have a copper atom with a mass of 64. So we have 1 of those. We've also got 2 times everything in this bracket. So we've got 2 oxygen atoms, so 2 times 16 for the oxygens, plus 2 times 1 for the hydrogens. So we have a total mass here of copper hydroxide of 98. In our last example here, we've got sodium sulfate. Here, for sodium sulfate, we have 2 sodium atoms, so 2 times 23 for the mass of the sodium atoms. We have 1 sulfur, which is 32, and we have 4 oxygens, so we have 4 times 16 for the oxygens. This is a total mass of 142 for each of for sodium sulfate. So these are all different examples of how you can calculate the formula mass of different compounds and molecules. Now remember, these numbers here that I've got are the masses from the periodic table, and they are multiplied by the number of each type of atom within the molecule or compound. So we've got 2 oxygen atoms here, each weighing 16, which is why we've got 32 for the mass here. If you have brackets, everything in the bracket is multiplied by this number afterwards, this subscript number here. So for this one, you're only having 4 times oxygen because there's no brackets, so it's not 4 times the sulfur because it would need to be in brackets if it was going to multiply the sulfur by 4. Now we know how to work out relative formula mass, we can use this to work out the number of moles of different molecules and compounds if we know their masses. So let's start off with oxygen as our first example. So with oxygen, let's say we have 5 grams of oxygen. We can calculate the relative formula mass of the oxygen because the relative formula mass is equal to 16 times 2. So the relative formula mass of oxygen is 32 because there are 2 oxygen atoms each weighing 16. Now, moles, if you remember, are calculated by doing mass divided by relative atomic mass. Now, because the units are the same here, because we are using exactly the same thing, we're just adding up all of the different relative atomic masses, we could also say that this was the relative formula mass. So we can either use relative atomic mass or relative formula mass to find moles. So in this particular situation, we're going to use the relative formula mass to find out the number of moles of our different compounds. So for oxygen, we have 5 grams of oxygen. We have the relative formula mass, which is 32. So 5 over 32, I'm just going to use my calculator. 5 over 32 is equal to 0.15 0.156 moles of oxygen. So if I've got 5 grams of oxygen, that equates to 0.156 moles of oxygen. So for another example, let's just look at aluminium oxide. So let's say we've got 3 grams of aluminium oxide, and we'd like to know the number of moles of aluminium oxide in 3 grams. So we need to find the relative formula mass of the aluminium oxide by doing 2, because there are 2 aluminiums, multiplied by 27, plus 16 times 3 for the 2 oxygens. So the relative formula mass, again, is 102. To find moles of aluminium oxide, this is equal to 3 divided by 102. So 3 over 102 is equal to 0.029 moles of aluminium oxide. If we bring this video together, we can see 2 key calculations that have arisen from it. So first of all, we can calculate moles by doing mass divided by relative atomic mass. So relative atomic mass obtained from the periodic table, that's the mass of each of the different elements. We can also find moles if we have a different formula. So we can find this for relative formula mass if we know the mass of a substance that we have. Now, I didn't mention earlier on, but sometimes you'll see relative formula mass as MR, which is relative molecular mass. Now, I've been quite careful not to use relative molecular mass throughout the video, because sometimes we're looking at compounds, such as sodium chloride, and sodium chloride is not a molecule, so I like to refer to it as relative formula mass, so we look at the mass of the different compounds. Oxygen, for example, is a molecule, so it would be correct to use relative molecular mass there. But to avoid confusion, I just use relative formula mass throughout. Thank you for watching. There'll be more videos coming online about mole calculations. So we're going to look at how do you calculate the mass produced in a chemical reaction using moles. We're also going to look at masses and volumes, and we're going to look at concentrations as well. And there'll be further videos to look at what happens with gases. So thank you for watching. Please like these videos, subscribe to the channel, and if possible, could you share these videos with everybody that you know?